Hello everyone, my name is Ku Chiu Mei and today I want to talk about our project background that is about a critical environment issue, the fast fashion industry. To understand the scale of the problem, let's look at the three alarming facts. First, the fashion sector is responsible for 10% of global carbon emissions. That is more than all international flights and maritime shipping combined. Second, we see a throwaway culture where one in three garments and are discarded after only one use. And third, when these clothes are sent to landfill, synthetic materials like polyester can take up to 200 years to decompose, releasing harmful microplastic into our soil and water. In Malaysia, this problem is growing rapidly. Most textile waste end up in landfills, and because different fabric types require completely different recycling process, mixed waste become impossible to recycle. Therefore, proper sorting is the most critical yet often overlooked step in the textile recycling process. Now, let's move to the problem statement. Currently, most Malaysian recycling facilities rely on manual sorting. This process is slow, physically tiring, and prone to human error. Because different fabric like cotton, polyester, and denim each require unique upcycling method, such as mechanical shredding for cotton or chemical depolymerization for polyester. Any mixing of these fabrics significantly drop the quality of the recycled material. The core problem is that there is currently no affordable, automated tools available for small-scale recycling centers in Malaysia to manage this efficiently.
I will explain about the objective of our SmartTex project. The first objective is to build an AI classification model by using Google Teachable Machine. The model can automatically identify three types of fabric, such as denim, cotton, and polyester. The second objective is to evaluate the model performance. We measure how accurately the model can recognize different fabric, texture, and pattern for all three fabric classes. The final objective is to support Sustainable Development Goal 12, or responsible consumption and production. Our system help improve fabric sorting, reduce textile waste, and support recycling by providing an automatic fabric classification tool. These three objectives guide the development of our SmartTex system.
Now let's continue to our project solution design. To solve this, we design a SmartTex. Our solution uses a 5-step automated process to replace slow manual sorting. It starts with an image input where the user can use a webcam for real-time classification or upload a video for static detection. The system then performs pre-processing automatically, resizing the image to 224 times 224 pixels to ensure consistent and accurate prediction using our mobile net backbone. Finally, the image is passed into our convolutional neural network model, built using Google Teachable Machine. The model analyzes the texture and visual feature of the fabric and display a confidence score for each class, denim, cotton, or polyester, each giving the user an instant accurate result.
Good morning, and today I'll explain our dataset and data collection. We collected a total of 1070 fabric images for our SmartTex project. The dataset includes 291 denim images, 383 cotton images, and 396 polyester images. We used two methods to collect the image. First, we capture our own fabric sample using a laptop webcam with a Google Teachable Machine. Second, we collected additional images from online sources to increase the variety of the dataset. We also took an image from different angles and under different lighting conditions. This helped the model learn different fabric texture and improve the classification accuracy. As shown in the bar chart, Polyester has the highest number of images, followed by the cotton and denim. A larger and more diverse dataset help the model make better prediction.
Hello everyone, my name is Narzuri Fahmara binti Muhammad Ishaq. Now let me explain how we train our SmartTex model. For this project, we use Google Teachable Machine, a free browser-based machine learning platform developed by Google. What makes this platform special is that it allows anyone to train an image classification model without writing any code at all, which makes it very accessible for our project. The algorithm behind our model is convolutional neural network or CNN, but instead of building a CNN from scratch, we use a technique called transfer learning. This means we took a pre-trained model called MobileNet, which was originally trained on millions of general images, and we retrained only its final classification layers using our own fabric images. This approach allows us to build an accurate model quickly and efficiently. Even with a relatively small dataset of only 10,000 images, for our training configuration, we set the epoch to 15, meaning the model went through all our training images 50 times to learn the pattern. We use a batch size of 16, which means 16 images were processed per training set, and our learning rate was set to 0.001, which is the standard settings for transfer learning tasks. One major advantage of this setup is that the trained model can run entirely in the browser using TensorFlow.js, meaning no server, no installation, and no internet connection is needed after the page loads. This keeps SmartTex fast, private, and accessible to anyone.
Now, I will continue to our SmartTex web application. To bring all this technology together, we have developed SmartTex AI-powered fabric classification system. We designed it to be user-friendly and easily accessible through any web browser. If you visit our site, you will find it structured into 4 key sections. Our home page is served as entry point to the system. Second, the About page. Details of the environmental impact of the fast fashion industry. And the How It's Work page. Explain the technical process behind our fabric classification. And the last page is our demo page. Is where you can try the system yourself. You can scan the QR code on the screen to explore the full platform right now. SmartTex is our contribution to make textile recycling smarter, faster, and more sustainable.
Now let us see SmartTex in action. The SmartTex system is a web-based application that allows users to classify textile materials quickly and accurately using artificial intelligence. The interface is designed to be simple and easy to use. No technical background is required. There are 2 modes available in SmartTex. The first mode is webcam modes, which enable real-time classification. To use this mode, the user simply opens the SmartTex website, selects the webcam mode, and point their camera at a fabric sample. The system will then automatically capture the image, analyze it using our trained AI model, and display the predicted fabric type along with the confidence score, all in real time. This mode is especially useful at a recycling center or bundle clothing shop where the workers need to sort fabric quickly on the spot. The second mode is image upload mode, which is used for static classification. In this mode, the user selects an image file of a fabric sample from their device and uploads it to the system. The AI model then analyzes the uploaded image and returns the classification result within seconds. This mode is great for users who already have photographed a fabric sample that they want to check. In both modes, the steps are the same. First, the user opens the SmartTex website. Second, they select either webcam mode or image upload mode. Third, they capture or upload a fabric image. Fourth, the AI model analyzes the image using our trained teachable machine model. And fifth, the predicted fabric type, whether it is denim, cotton, or polyester, along with the confidence score, is displayed clearly on the screen. As you can see in the demonstration here, the system responds almost instantly and provides a clear, easy to understand result. This proves that SmartTex is not just a theoretical concept, it is a fully functional working system that can be used in real-world settings today.
Hello, I'm Faiza Samir Khan. Now let's look at the results and model performance of SmartTex. Our model was trained on a total of 1070 images divided across 3 fabric categories. 291 images for denim with a test accuracy of 98 to 100%. 383 images of cotton reaching 97 to 100%. 396 polyester images also at 97 to 100%. This gives us an overall accuracy of 98.5%. What's particularly encouraging is that most predictions came with a confidence level between 97 and 100%, meaning the model is not just guessing. When it identifies a fabric, it is highly certain about that identification. As you can see from the examples on screen, whether it's the textured wave of denim, the soft surface of cotton, or the smooth finish of polyester, SmartTex consistently recognizes each material correctly and with high confidence. To put this in context, achieving 98.5% accuracy with just over 1000 training images shows that our approach is both efficient and effective. Let's now analyze these results in more detail. We found that denim was the easiest fabric to identify, and this makes sense because denim has a distinctive blue color and a clean twill wave pattern that makes it visually unique. On the other hand, cotton and polyester were the hardest to distinguish from each other. This is because both fabrics tend to have smooth surfaces and can appear very similar under certain lightning conditions. In fact, lightning turned out to be a significant factor affecting prediction accuracy. We also want to be transparent about the limitation of our current model. First, it only classifies 3 fabric types: denim, cotton, and polyester. Second, the model relies purely on visual features, meaning it cannot detect blended or mixed fabrics. And third, the denim category had fewer training images compared to the other two, which could potentially affect its robustness in real-world scenarios. So to conclude, SmartTex demonstrates that it is possible to build a practical fabric classification system using accessible AI tools without the need for advanced programming skills, expensive hardware, or massive datasets. With just 1070 training images, our model achieved 98.5% accuracy across 3 fabric types, making it well suited for textile recycling and applications. This project also supports SDG 12 responsible consumption and production by providing a free accessible tool that can help reduce textile waste through better sorting and recycling. Looking ahead, we have 3 recommendations. First, expand the model to recognize more fabric types beyond the current 3. Next, develop a mobile application to make the tool even more accessible in the field. Finally, the increased dataset diversity, especially in terms of lighting, conditions, angles, and fabric variations to improve generalizability. Thank you.